Yes. Acid dehydration is in which dehydration takes place in the presence of acid. Dehydration, that is removal of water in the presence of acid, that is acidic dehydration. ठीक है, सपोज जैसे acid dehydration कर रहे हैं तो उसके ਨਾਲ ਸਾਡੇ ਕੋਲ ਇਹ ਟੈਂਪਰੇਚਰ ਡਿਪੈਂਡੈਂਟ ਹੈ। अगर ਅਸੀਂ 443 Kelvin temperature यूज कर रहे हैं तो ਸਾਨੂੰ alkenes मिलते हैं। If we are using 413 Kelvin temperature, then it is ethers are formed. If it is 383 Kelvin, then alkyl hydrogen sulfates are formed. So it is temperature dependent. So acidic dehydration, there is removal of water in the presence of acid, is temperature dependent. At different temperatures, different products are formed. So if we treat alcohol at 443 Kelvin, then alkene is formed. So if it is CH3CH2OH ethyl alcohol, then ethene as a product is formed. And mechanism of dehydration is important. And this first alcohol is treated with acid H positive. Then H positive gets attached to oxygen through lone pair, and positive charges present as on oxygen. And then it is protonated alcohol. Then protonated alcohol loses water and positive charge is retained by carbon, that is ethyl carbocation is formed. And in the next step, hydrogen from the adjacent carbon is removed and we get ethene as a final product. So in dehydration at 443 Kelvin, alkenes are formed as a main products through protonated alcohol, and then is carbocation, and finally ethene is formed. Similarly, if alcohols are treated at 413 Kelvin, then we get ethers in which two molecules of alcohols react in the presence of sulfuric acid at 413 Kelvin to get ethers in which alkyl group is repeated besides oxygen, so it is ether. And in this mechanism, first two steps are same. That is, first is with acid, protonated alcohol is formed, and then alkyl formed in second step reacts with second molecule of alcohol to give this, in which alkyl groups gets attached to oxygen. This alkyl group gets attached to oxygen, and oxygen gets positive charge, and then this hydrogen is removed and we get ether as a final product. So at 443 Kelvin, specific conditions are required, that is sulfuric acid at 413 Kelvin gives ether as a main product, in which first two steps are same as in formation of alkene, and in the third step it reacts with second molecule of alcohol to get this, and then after removal of hydrogen we get ether as a final product. And if alcohols are treated at 83 Kelvin temperature, then alkyl hydrogen sulfates are formed, and the dehydration process. If we take another example, that is unsymmetrical alcohol. It is unsymmetrical alcohol because OH group is attached to carbon, which has dissimilar groups along both sides. One side CH3 group is present, other side ethyl group is present. So it is unsymmetrical alcohol. When it is treated at 443 Kelvin, then alkenes are formed. But in this case, two alkenes are possible. First is if OH group and hydrogen are removed from this side, then one butene will be formed. If OH and carbon are removed from this side, this carbon, then two butene will be formed. So if unsymmetrical alcohol is present, then two products are possible, but question is which alkene will be formed in major amount or which product will be a major product. Now it depends upon a rule, that is SADHAR rule. According to SADHAR's rule, that alkene is formed which is more alkylated. More alkylated means double bonded carbon atom must have more number of alkyl groups. In first, there is only one alkyl group attached to the double bond. In second, two alkyl groups are attached to the double bond. These two alkyl groups are attached. So it is more alkylated. So this must be a major product. This will be a major product and this will be a minor product. And so it is according to SADHAR's rule. So here SADHAR's rule is also important. Define SADHAR's rule. This we have already done in +2 also. So that this is acidic dehydration, that is removal of water in the presence of acid, and it is temperature dependent. In this, if temperature is 443, then alkenes are formed. If 413 Kelvin, then ethers are formed, and if it is 383, then alkyl hydrogen sulfates are formed. And it is very important. This question comes in exam directly or indirectly. So next is second reaction is oxidation. In oxidation, we have different reagents by which oxidation can be done. First is KMnO4. KMnO4 can be in aqueous solution or alkaline or acidified. And second is potassium dichromate in acidified, that is in acidic medium, or sodium dichromate in acidic medium. Then next is concentrated nitric acid, and last is chromic acid. So there are different reagents by which oxidation of alcohols can be done. Generally we use first two reagents to oxidize the alcohol. And this also the oxidation depends upon the type of alcohols. If alcohol is primary, then we get first aldehydes and then carboxylic acids. But aldehydes and carboxylic acids will have same number of carbon atoms as present in primary alcohol. Example, if it is CH3CH2OH, this upon oxidation will give CH3CH2 with same number of carbon atoms, aldehyde, and further oxidation gives CH3COH, carboxylic acid. But in secondary alcohols, first ketone is formed and then carboxylic acid, but ketone formed will have same number of carbon atoms, but carboxylic acid formed will have less number of carbon atoms. So, taking example, CH3COHCH3 means it is secondary alcohol. Upon oxidation gives CH3CH3 double bond O, means instead of OH double bond O, it is ketone, and upon further oxidation, one group is removed as formic acid, and further it is broken into carbonic acid plus water. So secondary alcohols give ketones with same number of carbon atoms, but carboxylic acids with less number of carbon atoms. And similarly, in tertiary alcohols, first ketones are formed with less number of carbon atoms, then carboxylic acids are formed, still less number of carbon atoms. In tertiary alcohols, carbon atoms are reduced in every step. So taking example, it is tertiary alcohol that ketones or aldehydes, it gives alkenes as a product. It gives alkene. So this three reactions can be asked in a single question, that is explain dehydrogenation in primary, secondary, tertiary alcohols or in different types of alcohols. So dehydrogenation is done with copper at 573 Kelvin. So this is all about the reactions in which alkyl group and hydroxyl group both are involved. So next is very important. How can we distinguish between primary, secondary and tertiary alcohols? There are two methods by which we can distinguish between primary, secondary and tertiary alcohols. First is Lucas test, Lucas test, and second is Lucas test. First we will start with Lucas test. In this, alcohols are treated with concentrated HCl. As we already know, HCl is less reactive, so anhydrous zinc chloride is used. Alcohol treated with concentrated HCl in the presence of anhydrous zinc chloride, haloalkenes, that is OH group is replaced with halogen. That is whether it is primary alcohol, whether it is secondary alcohol, or it is tertiary alcohol, and all we get the same product, that is haloalkane. Haloalkane is in all the alcohols. But question is their rate of appearance. That is in primary, start with alcohol. In tertiary alcohols, if tertiary alcohols are present, then turbidity will appear immediately when HCl and anhydrous added. Immediately turbidity or alkenes appears in. If appears, then it is tertiary alcohols. If turbidity appears after some time, then it is secondary alcohol. And if turbidity appears only after heating, then it is primary. So we can easily distinguish between primary, secondary, and tertiary alcohols depending on their rate of appearance of turbidity. If it appears immediately, then it is tertiary alcohol. If it appears after some time, then it is secondary. If it doesn't appear till heating, then it is primary. So second method is Victor's-Mills method. In Victor's method, we treat primary, secondary, tertiary alcohol with sequence of reagents. When it is treated, then finally if red color is formed, then it is primary alcohol. If blue color is formed, then it is red color is formed, then it is primary alcohol. If blue color is formed, then it is secondary alcohol, and if no color or no reaction, then it is tertiary alcohol. That is, when primary alcohol, secondary alcohol, and tertiary alcohols are treated with phosphorus plus iodine, all are treated with same reagents, then we get iodoalkanes. Then further, when it is treated with silver nitrite, all are treated with silver nitrite, then we get nitroalkanes. And then further, when it's treated with nitrous acid, It is nitrous acid. It is nitrous acid HNO2. When it is treated with nitrous acid, then water is removed. That is, then water is removed. That is H2 from this carbon, H2, and O from this HNO2, and we get NOH. NOH. Hydrogen from central carbon, and oxygen from this nitrous acid, and we get RC double bond NOH NO2. That is nitrolic acid with red color in alkaline solution. And similarly, when secondary alcohol is treated with nitrous acid after sequence of reactions, then it gives this product, that is cetonitrile. In this cetonitrile, this carbon has one hydrogen and one hydrogen from this and one oxygen. Water is removed and left us R2C NO2, and this is NO2. NO2 from nitrous acid. So this product formed is cetonitrile, and it gives blue color in alkaline solution. And on the other hand, tertiary alcohol, when treated with nitrous acid, it gives no reaction and solution is colorless. So by these sequence of reactions, then we can easily distinguish between primary, secondary, and tertiary alcohols. So there are generally two tests to distinguish between primary, secondary, tertiary alcohols. First is Lucas test, and second is Victor's Mears test. Now, there's one another reaction, that is iodoform. Iodoform reaction is important separately also. That is to describe briefly iodoform reaction, or how we can distinguish between two ketones and some compounds which have methyl ketone groups only give this reaction, which have methyl ketone groups. And one exception is CHOH, compounds with CH3CHOH group, and compounds with methyl ketone groups only give this reaction. That is when alcohol is treated with sodium hydroxide and iodine, we get iodoform with yellow PPT, and this yellow PPT shows that it has reacted, or the reactive molecule has CH3CHOH group or methyl ketone group is present in the reactant. And or we can take, instead of NaOH, sodium carbonate can also be taken, in which also yellow PPTs of iodoforms are formed. This test can example between ethanol and 1-propanol, 1-propanol, or can distinguish 2-butanol and 3-pentanol also. So there are the compounds in which can be distinguished. That is 1-butanol, 2-butanol, out of in which 2-butanol will give iodoform test, while it will not give. And similarly, if we take 2-pentanol and 3-pentanol, in this also iodoform test, this will not give iodoform test. So we can distinguish between primary, secondary, tertiary, and also between two ketones by iodoform test. So iodoform test is very important to distinguish and or to describe briefly. So it is all about the reactions in which both alkyl group and carboxyl group, hydroxyl group is involved. That is, first is acidic dehydration, second oxidation, third is dehydrogenation, and then the two tests to distinguish between primary, secondary, and tertiary alcohols. So this is all about alcohols. Next, we will start with glycols and glycerols. Glycols and glycerols. Glycols and glycerols. Glycols are glycols in which two carbons are present and two OH groups are present. So it is glycol. We will be doing about detail, that is its structure, its preparation, and its properties. Similarly, second compound in alcohols is glycerol. That is, this has three carbons. It has three carbons and three OH groups. That is, three OH groups are present at the adjacent positions. So these two compounds, glycol and glycerol, with polyhydroxyl groups, we will read further in the next lecture their separations and their properties in detail. In exam, generally 2-3 reactions come from glycol and 2-3 reactions from glycerol. So these topics are new and these cannot be ignored. And so in the next lecture we will continue with these two compounds. And now we stop sharing.